Hello everyone, this is Taboo Conspiracy 2. Very often when we address the silliness of NASA and fake space, we concentrate on the more technical mistakes, when simpler, common sense arguments are often overlooked. Now, don't get me wrong, I love the very large and growing collection of the hundreds of Apollo mistakes. Lighting errors, proving multiple light sources, pictures of the lunar rover not leaving tire tracks, repeated and mistaken use of the same cinema backdrops, obvious photo retouching, a light bulb sun, missing shadows, a lander that shows incorrect sides with respect to the same mountains in the background, alterations of photos by NASA, many other movie set mistakes, etc. I could go on for many hours pointing out these hundreds of mistakes, and I strongly suggest you go through the Jack White photograph studies located at aulis.com. But today, I'm going to commonsensically debunk the Apollo moon missions and the International Space Station. In law, there is a legal standard referred to as the reasonable prudent person. The standard is primarily the standard of care that a reasonably prudent person would observe under a given set of circumstances. For example, suppose a car brake malfunctioned, causing a death or injury, a horrible thing. In court, the injured party provides ample evidence indicating that the manufacturer never even attempted to test the brake on a vehicle before selling it, which then led to the injury. The court would maybe ask whether a reasonable, prudent person would sell untested brakes before it entered commerce, and most people would conclude that a brake manufacturer, especially being experts in the field, should reasonably test their brakes before selling them. It's common sense. We all expect that a chainsaw manufacturer would test its chainsaws before selling them to make certain that the chain doesn't fly off in the middle of cutting a tree. We'd expect a climbing harness company would make sure that its harnesses could actually hold a person before putting lives in danger. We would even expect vaccine manufacturers to test their vaccines with double-blind studies before selling them to the public. But alas, that's another conspiracy against humanity. As you can see, the reasonable, prudent person standard is a common sense approach to determine whether the conduct of a defendant would be considered negligent, or even grossly negligent, which would be important for punitive damages. Furthermore, if it is found that a person recklessly causes the death of another person, then the person could be charged with criminal reckless manslaughter. For his conduct to be reckless, the actor must have consciously disregarded a substantial and unjustifiable risk that death could result from his actions. Remember that. Consciously disregard a substantial and unjustifiable risk. Today, I want you to apply this hypothetical but common sense, reasonable, prudent person standard to both the Apollo moon missions and the International Space Station. I, and many others, have discussed this before, and so I'll try to cover it quickly, but look at the lunar lander. It's simply ridiculous. When you really look at it, it's hard to believe that NASA got away with this stupidity for so long. In addition to many unprecedented achievements that have not even been allegedly closely replicated in 50 years, this lunar lander spacecraft, which actually looks like it was built by a high school drama club, supposedly fell from lunar orbit at 4,000 miles per hour, or 4 times the speed of a bullet, and then landed on a dark, boulder and crater-infested, uneven, and dusty surface with very limited visibility and a limited ability to discern the terrain. This wafer-thin spaceship supposedly supported 2 astronauts for 3 days with multiple repressurizations in the harshest environment imaginable, and still included enough room to attach a totally unnecessary fold-up dune buggy for later flights. This story is completely ridiculous. But what makes the lunar lander story especially insane is the fact that the lunar lander was never flown on Earth. Not even once. Now, many people would counter that NASA astronauts had training vehicles. That's true. But these training vehicles were never dropped from an aircraft to simulate a fall from lunar orbit. And despite having much better visibility, these smaller training vehicles were never flown over rough, rocky areas similar to what astronauts would experience on the alleged moon. Astronauts trained by hiking with backpacks in rocky areas, but no one thought it expedient to actually practice flying the lunar lander or even a training vehicle in similar conditions. The training vehicles, at least the pictures and videos you can find, were only ever flown at airfields during the daytime. Ask yourself, how is that even close to training for the surface of the moon? There is no comparison. Moreover, 3 of these 5 much simpler training vehicles crashed during easy maneuvering over flat airfields, proving that NASA was incapable of designing a safe and much simpler vehicle. 3 out of 5 of the smaller and less complicated vehicles crashed in optimal conditions. This is not a good track record for safety. Now watch this short clip regarding Armstrong's near-death experience on one of these training vehicles.
The Lunar Module, or LEM, was the world's first true spacecraft. Nothing like it had ever been flown before. With its wafer-thin walls, the lander provided minimal shelter for the astronauts. Barely sturdy enough for its lunar mission, it was far too delicate to be flown or tested on Earth. NASA had to devise some sort of training simulator for their pilots. That's where this contraption came in. Armstrong activated the trainer for another landing simulation. Equipped with just enough fuel for a 6-minute flight, the trainer balanced on the thrust of its jet engine like a dinner plate on a broomstick. Each moment teetered on the brink of calamity. And then a thruster failed. Armstrong tried to compensate.
I can't say this with enough emphasis. The wafer-thin and delicate lunar lander, as stated in the video, was never flown on Earth in any manner. Moreover, the far simpler training vehicles were never flown in a manner to simulate any conditions which the astronauts would experience on the moon. And 3/5 of the training vehicles still crashed in easy and optimal but very inapplicable conditions. Now, would a reasonable, prudent person, especially a professional engineer, consider it safe to never actually practice flying a one-of-a-kind, awkward, and wafer-thin spaceship that would drop from lunar orbit at 4,000 miles per hour and land on such rough and unpredictable terrain? Only a liar would consider that safe. Of course, the more educated propagandist will claim that the astronauts did practice 2 times with a lunar lander in space during Apollo 9 and 10. But seriously, 2 times. But isn't it convenient that the only token flights of the lunar lander occurred in space, far away from independent cameras, and not on Earth, where the astronauts would really need to repeatedly practice on solid ground? Like landing. I'm sorry, but 2 flights in space is not proof of actual training. And the point remains. Those 2 alleged flights of the lunar lander in space were never even close to resembling a drop from lunar orbit 4,000 miles per hour and then landing on a rocky, crater-infested dust rock. These maneuvers were never practiced, and the lunar lander was never flown on Earth. No reasonable person would consider it safe to never actually fly the lunar lander in circumstances similar to what would be experienced on the moon. In fact, a reasonable, prudent person would consider sending astronauts to the moon 239,000 miles away in an untested vehicle entirely reckless. Reason dictates that NASA consciously acted, disregarding a substantial and unjustifiable risk that death could result from its actions, which would be considered reckless manslaughter if death occurred. However, there was one way that NASA was guaranteed to have 100% success in landing on the moon, and avoid the subsequent defunding of NASA and criminal manslaughter charges. And that is by faking the entire event. And there's ample evidence indicating that the event was filmed on a stage, as clearly evident by the fake stage backdrops visible during the entire alleged moon landing, and the wires, and so much more. Now, let's take a look at the International Space Station and apply a similar reasonable, prudent person standard. Watch this time lapse of the assembly of a Boeing 777X. As you'd expect, there's a time lapse showing the amount of work that goes into assembling a complex aircraft. You can watch hundreds of similar construction time lapses on YouTube, from houses to machinery, and even one or two NASA time lapses. But one thing you won't find is a time-lapse construction of the International Space Station. This video is all NASA offers as a time-lapse of the construction of the ISS. The ISS is supposed to be the most amazing engineering and technical marvel ever built, and NASA never thought about thoroughly videotaping the entire construction process, aside from a few silly clips. But here's the real kicker. The ISS was never even allegedly assembled on Earth. You, as a reasonable person, would think the fully 100% assembled ISS would undergo thousands of tests by engineers. But the fully assembled ISS was never tested on Earth. There is not a single photograph of the ISS pre-assembled in a warehouse where all of the necessary tests would take place. They want you to believe that several different countries all built different components of the ISS, but never felt the need to actually make sure that the components fit perfectly together, as even the slightest error would prove fatal for all the astronauts aboard. Think of the shared fittings, seals, and valves that all would need extensive testing. In one publication, NASA noted, quote, "Verification of structural safety is assured through stress analysis, loads testing, and non-destructive evaluation of susceptible structures. The pressurized modules that will be launched, that is to say those that are not test articles, undergo proof pressure testing and post-test inspections. In addition, module level leak checks are performed to ensure that the as-built modules meet leak requirements. Sealing mechanisms are qualification tested, and every seal is acceptance tested." So each of the modules of the ISS supposedly underwent these necessary pressure testings. But NASA didn't consider it necessary to undergo any tests of the entire ISS fully assembled, especially since the most likely place for a leak or failure would be between modules. What if something as simple as the air conditioning failed? All the astronauts would be dead, and yet no one tested the air conditioning with respect to the entire ISS? That's only one factor. Seeing a light in the sky at night that could be from a dressed-up fancy airplane or drone does not prove that there's a spaceship housing 6 people for nearly 20 years up in Earth orbit. It's nonsense. No reasonable, prudent person would consider it safe to not perform thousands of tests on the ISS, fully assembled in a warehouse, and every participant country would perform their own tests repeated ad nauseum with teams of engineers. And what if one of the seals failed? That was never tested and the astronauts all died. Again, NASA would be defunded and its administrators would face criminal reckless manslaughter for consciously disregarding a substantial and unjustifiable risk. I hope you see the nonsense of it all, as NASA would never have recklessly risked everything when faking space has a 100% chance of success, especially when you have an army of propagandists, famous shills, the media, all major institutions, academia, and all major governments supporting your lies. But there are so many more common sense arguments debunking both the Apollo moon missions and the ISS. And don't let the lying shills claim that we don't have the right to look and closely examine the reasonableness and recklessness of NASA, because that is exactly what thousands of people do every day in court. Now, I'll close with a segment from a Mark Sargent's professional series which includes a letter from a specialist in the valves and seals industry. As you listen to the video, remember that these miraculous valves and seals were never tested on Earth before sending the ISS in space. And I mean the valves and seals where the modules come together. You may also have to watch it again because I will be distracting you with a lot of NASA and International Space Station clips that are pretty funny. Anyway, thanks for watching, and God bless everybody.
So, per our conversation, I am sending you this letter. As we discussed, at this point, I must stay anonymous. The fluid control industry is a small village. Let us just say I am a professional in the valve industry. The point of this letter is to draw attention to certain aspects of seals, valves, and actuators that must be part of any artificial environment to maintain life and functionality. I have no special knowledge of the ISS, but there are principles of fluid and motion control that cannot be ignored. We assume that the ISS has supply systems for water, fuel, air, etc. These systems would all require valves, pumps, and seals at a bare minimum. Without systems to deliver, send, expel, vent, filter, and store these fluids and gases, life on board would be impossible. Tubing, pumps, tanks, and valves would need to be present across all of the living areas to assure, at the least, fresh air. Seals, such as O-rings, would be required throughout the ISS to hold in gases and fluids. Valves would be required to meter these gases and fluids and to maintain proper pressures. Actuators would be required to move devices such as the Canadian arm, hatch openings, etc. Anything that is not moved manually requires an actuator. Let's look at some of the questions that pose a problem. Okay, so that was the end of his little preface. And then he goes into, the first thing he wants to address is seals. And here we go. For aerospace applications, the most commonly used seals and O-ring materials, and we're going to get into a couple technical things here, are GLT-type fluorocarbons, generically ASTM D1418 type 3 elastomers. I don't know that word very well, which have a glass transition temperature of negative 30 Celsius. Materials of this type that meet the new AMS 7287 and predecessor AMSR 83485 specs have a useful operating temperature down to negative 40 Fahrenheit and up to 400 degrees Fahrenheit. Even though this is an impressive temperature range, it appears that the ISS is being exposed to temperatures beyond this range. There are special Teflon-based seals available that can extend a little past this range, but they are not made with flexible or compressible materials. Therefore, the mating components would have to be manufactured within a millionth of an inch tolerance to prevent a seal from moving and thus leaking. Not convenient for a hatch or a fuel valve that is in constant use. Perhaps the seals are shielded from the temperature changes. Perhaps. But the outside of the ISS does not seem to show the insulation units required to accomplish this. Another problem with seals is that they wear out. Seals would have to be replaced frequently. Preventative maintenance of seals and sealing services would keep a maintenance team busy 24 hours a day. Seal replacement would require sealing off areas, cleaning and sealing surfaces, since in many cases a human hair can cause a seal to leak, lubrication, polishing sealing surfaces, or replacement of modules, etc. I do not think any of these things have been observed on the ISS. Seals also require back pressure to seal. I have no idea how a seal would function against a vacuum. We have no calculation for it. Any seal I have ever seen would simply be sucked out into space. How fuel, air, water, etc. are all contained and moved in the ISS, I have no idea. The seals of the ISS must be flawless, maintenance-free, immune to temperature changes, basically miracles of modern science. We in the industry would hold such mythical seals in awe and reverence if they existed. He says valves would be needed aboard the ISS for many life-sustaining reasons: fuel, air, water, ammonia, etc., etc. And then he takes an excerpt from literally space.com, right? And this is from the guys that are up there, right? So this is their quote. He says, and then he comments on it. So it says the International Space Station's active thermal control systems, the ATCS, pump fluids through closed-loop pipes. A liquid ammonia coolant loop along the station's main truss keeps the station's electricity-generating solar panels cool. An ammonia pump on the main truss failed in 2010 and had to be replaced by spacewalking astronauts. The Expedition 35 crew on the International Space Station reported an ammonia leak near that same location 3 years later in 2013. Liquid ammonia circulates through the pipes, carrying waste heat from the solar panels to the photovoltaic radiator panels, where the heat escapes into space. This keeps the solar panels cool. So then he comments. He says, so there it is, the ammonia is pumped. Pumping requires valves. What valve can function in extreme temperatures in a vacuum? Since a spacewalk was required to repair the unit, it is obviously exposed to the vacuum of space. The seal issue mentioned above would be a major problem. How would they perform degaussing? And people don't know what that is. It's the process of decreasing or eliminating a remnant magnetic field of the valve for it to function properly, since they are never grounded. When these astronauts replaced the pump, how was this accomplished without depressurizing the entire ammonia supply? How does one do that in a vacuum? I watched this procedure on space.com. It was clearly done underwater. Plastic pieces floated upwards, etc. No residual ammonia and the broken pump was emitted. No lubrication applied. The list goes on. Valves require venting. Excess pressure has to go somewhere. Is it vented into space? Would that not suck all the gases and fluids out into the vacuum of space, since there is no back pressure in space? Are gas valves vented to the interior of the space station, increasing the pressure in the living areas to dangerous levels? Valves require filtering. Are filters changed frequently? Are there 3 maintenance teams working 24/7 to maintain the filters? Because if a filter fails and stops a valve, it could kill everyone on board. Consider a commercial airliner. Consider how much maintenance one airliner needs to stay in the air. Think about the fuel pumps, the air exchange, and the seal replacement programs. Valves are maintained and changed out frequently. Now consider the ISS in this light. One little pump's change out in 2010 and a little repair in 2013. Does NASA have valves that function in impossible environments and seals made of unobtainium and unicorn tears? I am guessing no. Actuators, or air cylinders, are the muscles of moving machinery. Pumps are the heart of the machinery that pump fluids and gases to drive the machines. Valves control the pressures and quantities of the fluids and gases. Actuators push and pull to give the machines movement. They have been used for decades to drive the Industrial Revolution forward. They are the muscles of robots that move their limbs. They hold the hood open on your car so you can check the oil. They open and close the hatches on submarines. They drive needles that weave carpets. They are all around us in every mechanical system. Some are driven with pneumatic air pressure. Some use hydraulic fluids, and some are electrical. Let us look at the types briefly. Pneumatic, otherwise air-driven. On the ISS, how would these work? The seal issue is certainly a big problem. Actuators need valves. We covered these problems already. Piston rods rely on dynamic seals and are prone to leakage. Temperature is an issue. Ice cream makers and metal forges struggle with actuators due to the extreme temperatures that they deal with. But consider that they only deal with their end of the temperature range. Ice cream makers deal only with extreme cold. Metal forges deal only with extreme heat. What kind of Vulcan technology, and I'm sure that's a Star Trek reference there, is NASA using to handle both temperature extremes, let alone in a vacuum? Hydraulic or fluid driven. The same problems as pneumatics apply here as well. In addition, hydraulic actuators drip and weep oil. The ISS would become uninhabitable without constant maintenance. Where would the fluid be stored, disposed of, replaced, etc.? Electronic. This is probably the most probable type NASA would claim that they use. They are clean and function without the exchange of pressurized substances. What about maintenance, lubrication, degaussing, replacing motors, drives, belts, circuits, panels? Certainly, they would be prone to shorting out and requiring constant care, especially since they cannot be grounded. Consider satellites, but that's another topic. Changing out components is not like changing the brush heads on a vacuum cleaner. Lastly, and probably the most important problem, is there's no machine shop. All dynamic systems require installation and maintenance. No matter how carefully designed and how advanced a system is, something will require machining. All large Navy craft, I'm looking at you, Sean, have onboard machine shops. The reason that I use ships and submarines as examples is that they are the most similar systems to the ISS that we can relate to. They are moving, large, self-contained, and functioning in hostile environments. Navy vessels must be able to repair, modify, or replace anything on board. Even under the best conditions, metal will warp, screw threads will strip out, seals will leak, welds will break, metal sealing surfaces will get scratched, tubes will crack, electronics will short out, motors will overheat, motors will freeze up, critical tools will break, belts will break, cables will snap, etc., etc. The ISS appears to not have a machine shop whatsoever. How are repairs done? Are we to believe that all the replacement parts are flawless modules that snap together perfectly every time like Legos? Are there sea containers full of replacement parts floating next door? Is there never a time that a critical threaded hole is stripped out and needs to be retapped? Do parts never warp in the extreme temperatures and need to be resurfaced? Is there welding equipment up there? Submarines have welding equipment. They can even weld underwater. What happens in the event of a structural event that requires welding? I know that Captain Kirk and Spock repairing the Enterprise using a phaser as a welder, but this is supposed to be real. Of course, the chance of fire is too great to weld, but structural damage happens and has to be calculated into the plan. As far as I know, it's not. Regarding fire hazards, machine shops throw sparks, lots of sparks. Even if you could haul a lathe, Bridgeport, and drill press up to the ISS, the danger would be too extreme. This is where NASA shot themselves in the foot. For short missions, days, even weeks, this would not be an issue. But when the missions are years long, no. The ISS is great theater, but it is not reality. Thank you, the Valve Guy.